This is a tutorial of a tool called Pickaxe. Pickaxe is a web scraper, so it scrapes data from web pages using a SQL-like syntax. So if you know SQL and a little bit about CSS, this is the tool for you. What I want to do, I want to show a demo of scraping a form. This is a form that I'm hosting that has just basically question and answers. So here you'll see question. This one has 5 different replies to that topic. I want to be able to get all the data from this website. So the first thing we need to do is I need to be able to get these page numbers so I can go and get all the pages. So you'll notice that it has multiple pages of posts here. So this will be the first page. So to do that, we're going to use this tool. First thing I want to show is the download page statement. So if we download this page, if we just run it, the code, you'll see that download page returns just a table, like a SQL table. And in it is the URL that we just downloaded. You'll notice in the messages it says download succeeded, so it actually downloaded this page. The download page statement actually downloads the HTML from that page and shows you a table view of it. The nodes represent all the HTML nodes, and we'll talk about what you can do with them later. And the date is the date that it was scraped, and the size, 13K. So now we can say something like where nodes. So since this is a table, I can say where nodes equals something. And this equals something is going to be a CSS selector. So what I can do, I'm using Chrome here. And in Chrome, if you hit F12, you can bring up the Chrome tools. And you can basically use these little hover tools to figure out what the HTML looks like. And with the way the where statement works in Pickaxe language, in the tool, is that when you do a where clause, you can limit the HTML of the page just to the portion inside the where clause. So I'm going to say, I want to pick up the CSS class page nav. I want to say limit the page to only nodes underneath nodes that have the CSS class. And in this tool, in this page, the only node that has page div class is just this one. So we're going to get all these nodes in our select statement. We'll be able to go through all these nodes. And what I really want is the number 1 and 49. That'll give me all these pages. And to do that, there's a pick statement. So instead of saying select star, we can say select pick. And I want to pick this first list item with the class of current. So I'd say, and what I can say is I can take the text. So once you pick, you can say take text. You can also say take attribute, which I'm going to show in a little bit later. And you can name the attribute here. But for now, we just want to take the text. If you run this, see that we get 1. But we also want to get 49. So here I'm going to say the nth child, 1, 2, 3, 4, 5, 6, 7. The 7th child in this case. And I want to take the text of that as well. You notice that there's nice syntax highlighting here. And I just got an error of unsupported CSS selector. So I typed this one. You need to have a colon there. I run this, you'll see that I get 1 and 49 in a nice SQL-like table structure because I selected these 2 elements out. Remember, the where statement limits the page to just nodes under here, and then I selected the 2 nodes out of there, nodes under there. So that's why I get 1 row of these 2 guys. Now we need to store this. I need to store this in a variable. And so the scrape language Pickaxe allows me to create kind of table structures. So if I say create buffer, I'm going to create an in-memory table. I'm going to call this one I'm going to call this post pages. I want the start page and end page. And these are both going to be integers because we see that they're 1 and 49. And I want to say insert into, just like you would do in SQL, insert into post pages. Now if I run that, you'll notice that I don't get any output in this result window. But I can say select star from post pages, just like you would in SQL. And now you notice that I get a table like before, but now the columns are start page, end page, because they mimic this buffer right here. So now you've seen just a little bit of code. I've actually downloaded a page and picked out portions of the page that I wanted. And I didn't have to write mounds of code like you usually have to. Mounds of PHP or C#, whatever language it be. So now what I want to do is I want to basically generate all the pages from 1 to 49. And to do that, there's an expand statement. So I can say, I'll just give you a little example here. So I can say 1 to say 50. I run this. It'll give me a table, just like the download statement gives me a SQL table. The expand gives me a SQL table. And it just gives me a column called value. And I can see that I generate all the numbers between 1 and 50. This is really, really useful for paging algorithms. I can also, for more complicated paging algorithms, there's this, you can also do a little statement here. So if I did something like this, if I want to generate like 11, 21, 31, 41 or something similar to that, I can do $sign will always, $sign will be the numbers 1 through 50, and I'm saying times 10 plus 1. So now you'll see I'm generating 11, 21, 31, 41, 51, blah, blah, blah. So this is really, the expand statement is what you want to use when you're generating pages to visit. Because most of the time you'll find when you're scraping web pages is that they're going to have some kind of paging scheme. Like, you know, in this case, it's going to have page 1, page 2, page 3. Sometimes they'll have like page 10, page 20, page 30. So we're going to use this expand statement. First, we want to go through all the post pages. So there's a loop. There's a construct called each statement. So I'm going to say for each row in the post pages, I want to go through and expand. I want to generate all the pages to visit, because what I want to do is I want to visit each one of these pages. I want to get the URLs to visit. So here, I want something like this. I'll explain this in a second. We're going to create another buffer. Post pages. This will represent all the pages of the postings. We're going to visit all these summary pages. You'll see the email index. We're going to generate all these URLs right now. Index 2, index 3. And this will be we're just going to call it a string URL, and it's going to be a string. We're going to insert that here into the details URLs. So here what it's doing, this is going to come actually a little bit later, confusing myself. What we want to do now, this is how we actually visit each one of the pages once we're done generating the URLs. But what we want to do first is we want to be able to for each one of the post pages, we want to create page URLs. So let's look and see here. So what this is doing is it has the expand statement. We're going from the row start page and end page, and the row is from this post pages, which I just showed you, which I ran earlier. So we're going to go from 1 to 49, row start page, row end page, because we're going through each one of the rows of these tables, which would represent 1 to 49. And then we're going to just like normal SQL, you can put strings before and after the value. Remember, the expand statement has a value column. So when we run this, you can also just highlight the statements you want to run. And then if we run it up to there, you'll see that I'm getting all the pages, all 49 of the pages with the full URL in them. So if I just take one of these, and I go to here and I put it in, you'll see that I'm going through each page. So I have all my 49 URLs now. So now what we want to do is go through all of those URLs and pick out the link, the main link. So what I want to do is I want to pick out these links out of each of these pages so I can go to the detail pages. And that's why this right here is called the post pages, the detail URLs. Let's get the detail URLs. So we need to go through all the page URLs, which I just got, and put them into these detail URLs. So let's just test this really quick, and I'll show you kind of what it's doing. Let's pull this out, and let's take one of these just to hard code it. So you'll see if I run it on this page, we are going to pick out the first part of this statement says, limit the page to only divs that have the topic class. So we look here, here's a div that has the topic class. Here's a bunch of divs. See all these? They all have divs of the topic class. So these are all the posts. So that's our where clause. Inside of there, we're going to pick out the H3 tag, and under there the anchor, and we're going to take the attribute. Remember I said you can take attributes instead of take text, href. So basically it's going to take this guy, this href, topic index 3417. And that's what we see here, topic index 3417. So when I run this, I get all 10 for that one page. I get all the 10 detail links. And the fully qualified detail links too. Because we're going to do the same thing. We're going to append on, since it's a relative URL here, we're going to append on the main form page. So when I do this, when I run this and I select all the detail URLs, I should end up with all the posts. So we'll let that run. You'll see that when it runs, it tells you how many pages is downloaded. And then here we go. So now it's printing out all the detail URLs right here. Select star detail URLs. These are all the post URLs. And there are 485 posts. So if we were to go in this form has a total of 485 different posts that I want to get. So now that we have all the URLs, the details, I want to get the subject, the post, and all the replies. So we're going to do all the same stuff we did before, nothing different. We're going to use the where statement and the pick statements to pick stuff out of the pages that we want. We don't need this expand statement anymore. So to do that, we're going to look at something like this, which I'll explain. So here we're going to create two buffers. One is the topic details, which represents the string, the post, and user. You'll notice that there's an identity column here. The identity column auto increments. So every time I insert into this buffer with select statements, it's going to be 1, 2, 3, 4, 5. Just the same as SQL. MS SQL has identity columns. It's the same thing. You'll notice here that we download the page once. So in the previous examples, in the from statement, we just put the download page in line, but you can also store it in a variable because here we have two select statements selecting out of the same page. So we want to download the page into a table first and then have two from statements right there. So we don't download it multiple times. So let's look at this one first here. So let's just grab one of these URLs from a detailed topic here. And you'll notice that we have another loop, another each loop, where we go through all the detail URLs, which are all these guys. And we download the row.url, which is a property of detail URL. See? So that's a column in that table. So now let's just test this first one out here. I just want to do what we did last time, kind of bring it out, give it a test. Let's basically try to do, let's just look at this page and see if the statement's working. So if we run this, you notice that we get the subject and the post and the name of the person that posted. And this is working the same way as everything does. So the where statement says limit that page to a div and a topic. So if we look at this page, see if I can grab it here. Okay, so this is, you notice that here's a div and it's a topic class, and the replies are a div in the replies class. And you'll see that down here is our where clause is div reply for all the replies. Here it's div topic. And under the div topic, we have the h3, which is our first pick statement. Pick the h3 under there, take the text. This one is pick the paragraph that's the nth child of 3. Nth child 1, 2, 3 is the paragraph, and that has the post. And then we look at the paragraph that has the author, paragraph tag that has the author, which is here. Pick p.author, take the anchor, take the text under there, which is right here. So we're taking that name. So that seems to be working pretty well. And then this is just the same thing, except now we're taking the identity, which is the same as MS SQL Server works. This gives you the last inserted row. So when this runs, it's going to insert this data into this table, and then the identity is going to increment, and then I can get that value of that identity here. Because every time we go through this loop of all these URLs, so this is kind of like acts as like a foreign key back into the topic details. So first time this will be 1, and then there'll be multiple ones of these because there's multiple replies per post. So if we do the same test here, just pull this out and see how it works. We're not going to have these defined. And then let's get this guy. Download page. See, now we get 4 rows. And you'll see that these correspond to the Vitesse story, Martin William. So you can run this multiple times, and you can highlight any statements and run them. So see, that's working. So now if you run this, let's just, at the end, let's just print out all the topic replies. This is going to be pretty cool. This is where the language really excels, because this is all the code I had to write to get all the posts out. Now if we just run the whole thing, you'll watch that we're downloading stuff. So here we're downloading all the, basically going through all of these pages. Right, home index 2, home index 3. So now we're going through all the topic details. So here's the, you see the URLs change the topic. And there's, 540 of them, or there's less than that, but this tells you, this number tells you the total number of operations it needs to go through. So it's kind of clicking along. As we wait for this to run, we can kind of watch it run. You might be saying to yourself, well, this is great, but how do I actually store, since create buffer stores everything in memory, how do I actually save this once the program is done? So there's two types of tables you can create. You can create buffer tables or file tables. And file tables are wrappers around the actual file. So I can do something like this. This is where it's really kind of fun. And I can edit code while it's running. I just can't rerun it. I can only stop it while it's running. So what this is saying, oh, create a file named topic details with these columns and separate the fields of each row with pipe and make a new line at a row terminator. So there's field terminators and row terminators. And then save it. I'm going to save it in this directory here. I'm going to call it topicdetails.txt. So now without changing any code, I'm just changing how the table behaves. So instead of a buffer table, I'm going to make it a file table. This is pretty powerful, because now I can save results to files. So you'll notice that when I was doing that, the program stopped or it's done. So it says ready, and I can hit the run button again. But here's all the columns of the replies. So I just printed those out. So you'll see that we have a lot of replies, 4,667 different replies in this whole form. Here's what everyone's saying. Here's the URL to the details. Here's who said it. So nice little rows there. So now what I'm going to do is I want to show how we can write these to a file. And this needs to be topic replies and topic details. Let's just see if I did that right. Let's just highlight these and run it to make sure it worked. Parse error at line 9. So you'll see when you get an error, since I only highlighted these statements, it's going to be line 9 within these highlights. So I just have to go 1, 2, 3, 4, 8, 9. So it doesn't like this. And you'll see that I need to say create file instead of buffer, because create file has more statements that you have to specify. So when I run this now, what I expect to get is two files with pipes between the rows, between the columns, pipes between the columns, and new lines between the rows. So let's just give this a run again. You'll see what will happen if we just kind of watch the file system at the same time. You'll see that here it just created two files, popped in, and we can watch their size changing dynamically. Each time you write a row to the table with an insert into statement, it's going to append data to the file. So you see it's getting big pretty quick. Now it's 1.5 megs, 1.6, 7. We're about 60% done now. Files just continue to grow. And when this whole program's done, we can actually look at the files. So it's still going to select stuff out of here because I still have a select statement down here at the bottom. So it'll still show stuff inside the editor. But now if I go to these text files, you'll see the topic details has all the topics, just like we saw on the table. But here it's in a file, and it's pipe delimited between columns. See pipe, pipe. So here's the post. And then if we want to see all the replies for post number 1, you just have to open up this guy, and you'll see here's all the replies for post number 1. You can see how the foreign key kind of acts like a foreign key. In our code, we had that add identity thing, which links it to the first post. The first post had 1, 2, 3, 4, 5, 6, 7, 8 replies. The second post had these replies. And it's all nice pipe delimit. So now you can do a bulk insert to MS SQL Server if you want, or however you want to use the data after that. This tool is just kind of a bridge between files and HTML and the internet. So that's kind of the basics of the language. I wanted to show you also something. So it becomes pretty apparent if you scrape websites often that sometimes you need proxies. And proxy statements have to go at the very top. So if I put a proxy statement at the top, what this is saying I want to use these proxies. If you want, I usually use US proxies. There's a site that shows free proxies. So if you go to US proxy, if you type US proxies into Google, usproxy.org, you'll see that lists all these proxies. These are free proxies. So these are good proxies to get, and you can copy these into the program. So it's IP address :port, comma, IP address :port, IP address :port. You can put as many proxies as you want in here. Here's another cool thing. You can say with test. So this is giving it a test. And if this test is just a simple select statement, if this test returns more than 1 or returns more than 0 rows, if it returns rows, it succeeds. It assumes the proxy is able to download this page and select something out of it. So as our test, we're going to say, we're picking the tagline out of the page. So this is the tagline right here. So we're saying we don't need a where statement here because we don't need to limit the page. We're just saying, hey, take the tagline out. And so if we run it, we say, what's happening? See that? That's the tagline. So you can run this. So you can just run this by itself, and it'll test each proxy with this select statement. So you'll see that the first proxy passed, and it's testing the second one, and it'll test the third one. And when you run this with your program, it'll only use the proxies that succeeded to run the rest of the program. So the second one had a problem. See, this second proxy failed. It couldn't connect to the remote server, and the third proxy succeeded. Another cool thing, just to show this is working, is you can. So this is kind of cool statement. So here I'm going to I want to show my IP address. So what I'm going to do is I'm going to actually scrape this page. So this should show one of these proxied IP addresses. If it's working correctly, we should get 206. So you see that now all of them passed. And if I run this, I get 206, 142. So it's showing the first proxy IP address. So now I know that my proxies are working correctly, because I basically went to a site that's what's my IP address, and out came my IP address, except it's not my IP address, it's the proxy, it's the IP address. So now if we just run this again, it's going to test the proxies, and then it's going to use them. So you'll see that here it is. So you'll see that when in your messages, you'll see it's going a lot slower because it's going through proxies, but you'll see that it round robins the proxies. So first it uses 206.1, then it uses 156, 162. So it round robins between them as it runs your program if you use proxies. That's kind of a nice feature. And if we just run this again, it's just going to reappend to our files the same way it did before. So these files are just going to grow with new data. So that is the first tutorial. This is the basics tutorial of how to use the language. So from this, you should be able to write simple scrapers, and it can be used to scrape all kinds of web pages. In the next couple tutorials, I'll show a little bit more complex features. But with these basic features, you can do pretty much a lot of things. So you'll notice that this is going to run a lot slower because it's going through the proxies. And you can always stop a program. You just hit stop and we'll abort. So happy scraping.